Hi guys, so today we are going to learn about Google Street View HLD problem. So in this particular video, we are going to discuss in very general manner, starting from the functional requirement, non-functional requirement, capacity estimation, APIs, data models, and then we will start from like basic design and then we will go into deep dives. So here we will try to explore multiple scenarios. We will try to understand the problem. Even though if you are not aware like how the systems usually work, this video might help you. So let's start. Let's understand what do you mean by Google Street over here. Uh, and when we go inside, so I will select randomly any particular place. Here if you can see, we can just go inside this place, we can just zoom in little bit, and if I click over here I can get an option, street view, right? If I click, then here you can see this is the particular place. If I will click, so from here this particular option we can rotate it in 360-degree view. You can see, right? Also, if you will place your arrow over here, you can move forward in any of the direction. So here you can see I can move like this. But one thing you can observe that you are able to see people, you are able to see some vehicle, but the faces of the people and the number plates are blurred. That is the beauty of each. See here you are not able to see the number plate, correct? So this is the kind of a design system that we are going to design. So let's get back to it. Now what are our functional requirements? Functional requirements here is user can zoom in or out, then user can select any street, then user can after clicking on the street, user can rotate in 360-degree view, hide face and vehicle numbers of all the objects. Then we can also include what else. First of all, we are able to see one image. Okay, one more thing is we user can move in two direction, that is moving forward or backward. And it's like basically we are giving the feel of moving on the streets, right? So these are our functional requirement. Let's talk about non-functional requirements over here. So before even speaking about non-functional requirement, let's discuss like how basically Google is collecting the street view and images. If you can car for Google image, you can see the Google cars. See this is a kind of a car, Google car, which is having the 360-degree camera view. It is rotating continuously and clicking the pictures whenever the car is moving from the particular street. Okay, so now we got an idea that how all the images are being captured and lots of cars are moving in multiple directions. One more thing is there would be, I mean, there are around 50 million kilometers road, but as of now Google is able to capture only like 10 million kilometer road. So there are so many unexplored streets as of now. Okay, coming back to this particular non-functional requirement. Here we want that whenever we are searching, we observe that the images were loading very faster, right? So we need low latency. Then that means that in less than 200 or 300 milliseconds we need to load all the images, and also like in less than 200 or maybe like 100 milliseconds we need to load the nearby images as well, because we are also providing the functionality of like moving backward and forward from that particular cell. Okay, another point we can discuss is, according to the cap theorem, we can have the consistency and availability trade-off, and as this is a distributed system, we can have some functionalities or some features are highly available and some features would be highly consistent. So here what so here our highly available feature would be like while searching or clicking the images, the whole system needs to be available. So here you can consider that our whole system, like searching street, or maybe like getting all the images, or like not getting but fetching all images, all of these things needs to be highly available, and it should not get down. Available. Another point is eventual consistency. Why eventual consistency? Because whenever these cars are collecting the images, it will take lot of time to process that particular raw image, because we need to blur the faces, we need to blur the images. Also, like when this particular camera is been rotating, it's not like collecting the image in panorama form. It might be, like there are 15 to 20 images and it is stitching together to get a feel of like, okay, we are moving in 360 degree. So that is also one important point. And another process, it will be having like, or not all the users will be using laptop or iPad. Some of the users are also using from their phone, so the resolution we need to make sure that if it is from mobile, then we need to send those kind of resolution images. So these are some of the processes which are taken care, and then all of these things are being uploaded. So because of these all reasons, so like uploading images, it needs to be like eventual consistent. So if you think in real world, so if you think as in real world, this particular thing will require or takes years and years and months to actually get the to actually store this all the images. And here if you will see the street view, okay, let me just get zoom in this. Okay, now here you can see the last updated was April 2026, and this is as of now June. So not every day you are, like if you have clicked the image today and you are going to upload it, because there are a lot of processes which is going on. So we are first of all collecting the raw images, and the uploading will take time, and we will show this all the images to the people who are living or residing in that particular region first. So that's how, like, the people who are living far, we can, like, they will take little bit, like, time to receive this all updates. Okay, apart from this, our system needs to be highly scalable to accommodate more streets, and it also needs to be durable enough so that all the images that we are storing, it should not be deleted. Another thing, it needs to be reliable, that whatever images that we are showing, it's correct. It should not be like wrong images. Another thing you can include is consistency. What needs to be highly consistent? Okay, highly consistent should be like some of the features, such as like the cell you are clicking, it should show those images only of the particular cell. It should not show some other cells images. So that needs to be highly consistent. Yeah, I think pretty much we have covered the non-functional requirement over here. Now let's talk about capacity estimation. So in capacity estimation, you can consider there are 100 million daily active users, but not all these people are going to use the street view. We can consider there are 20 million daily active users who are going to use street view, and out of which if we want to calculate the QPS, so query per second would be 20 million upon 10 to the power 5. This is like easier way to find out QPS. So million is 10 to the power 6 upon 5, so 200 requests per second. And if we want to calculate the peak query per second, here you just need to multiply it by 10. So this is the maximum peak or traffic you will get. So it's 2000 requests per second. Now let's talk about the storage capacity estimation. You can consider, suppose we are collecting one raw image. So one image, it might take around 300 MB, and suppose we are collecting around 10 million images per day, then suppose that means we have 10 million into 300 MB of data, which will be around 3000 million megabytes of the data that we are going to store. This is for per day. So to simplify this, it is around 3 million, then billion into 10 to the power 6. So 3 petabytes of data per day. Okay. Here you can consider that 3 petabytes of data is very huge. So here, because of this reason, we are going to consider our like S3 storage, or you can consider like object storage. Now here one question will pop up in your mind, that when we are when the cars are moving, right, at that time all the images are being stored in a disk format. Now how they are going to upload it via like this in S3 or object storage? You can consider one scenario. Suppose one car is moving continuously for like suppose 15 days trip, and at that time suppose it is a remote area, and over there the network is not been like internet is not available. So how they are going to upload it? Here the possible scenarios would be like the cars are continuously moving. Some people from the warehouse will go to this particular location where car is there, and they will collect the disk which are already filled with the images, and this particular person from the warehouse will give them the empty disk files, so that because here we don't want that our cars to stop working or we stop uploading the images. If the internet is fine, but imagine that if you have petabytes of data, how you are going to upload it with just a minimum like minimal bandwidth, right? If you imagine that while uploading your GB of video, it might take 1 or 2 hours if you are uploading from your mobile network. So it's better to go with option one, that is like a people from warehouse will collect this, and you have to make sure the disk which are there, it's not been corrupted, or there should be a proper boxing of it, because we don't want an unauthorized person to use this data. There should be a tampered box where any of the calamities where any of the natural calamities happens, it doesn't like break this particular box. So these are the possible scenarios which you can discuss in the interview. um, so you know that like all the cars and then cameras, the boxes, disk, everything is very expensive, also time is very expensive. And you can also see that in some street view you can see like every month they are uploading new images, latest images. But for some of the areas where people are not like searching the streets, those images are like previous years or maybe like 2 years ago, something like that. So this is how the flow will look like. Now let's talk about the APIs. API design. Here we will discuss like uploading image, then fetching images. These are the two APIs we can discuss in depth. So for uploading image, we can have like post API. It would be like post imaginary upload that particular image is upload, and in response it will give you 200 response. Another thing is we also need like fetching images. It's a get API. Here we are getting panorama images. Here we can pass on the latitude and longitude, whatever it is, and in response we will get the we are, if you will see in this particular street view, if I just click inspect, and here if you see the network call, suppose let me just increase, okay, and if I will move in the forward direction, you can see a lot of tiles are being loaded. So you can see the different images are being loaded. These are the street pixel views. Here you can see the images, right? Within just seconds it is been loading all the images. So how this is working as of now, before this you are able to see the overview, like top level view, map view, and when you zoom in, at that time in your nearby CDNs or cache, you all of these images will be fetched and stored over there. Now if you will click over here, and then here you can just see street view. So all of these images, nearby images, and like along around 500 meters of area images are being collected in your nearby CDN. It's very easy, and in very fast way it can like capture all the images. So that's how the low latency we can take care of it. Okay, now coming back to our design. Okay, in response we are getting the list of all the tiles, and it would be like in image form. So it's tiles underscore 1 dot png, tiles underscore 2 dot png, something like that. And if we are moving forward, so in this get panorama, we are going to like pass on in the body that we are moving direction we are passing as forward, and also we are clicking, right? So there would be the meters, so we can pass on the number. Here we can pass on the current panorama ID, so that it will bring us like maybe like suppose 10-meter forward or 10-meter backward, something like that, and it will give you the response, and the same response will be there. So this is how the APIs will look like. So now let's move towards the data modeling part. Here we can discuss what all tables we need. First of all, we need image, or maybe we can need image table, we need panorama table, we also need the street table to store the street IDs, and the image we can attach to it. Apart from that, do we need sometimes what happens, we need the versioning of that image, or maybe like history, so that we can track, but it's fine, we can store it in our panorama table. Also have panorama connection table. Okay, now let's talk about what all fields will be inside it. Image will have the image id. This all images are the raw image, so we can store it in it. It's just for our use case, just in case if we need it for the future R&D purpose. For panorama table, we can have the panorama id as our primary key. Like apart from image id, we can also have latitude, longitude, created at timestamp, also like okay, what happened, version, because every time we will store it in the latest version, and we will be having as an url. This would be our s3 storage bucket id. Yeah, this makes sense. Panorama, it's just kind of like a proper image for that particular latitude and longitude. So have the street id as our foreign key. Apart from this, we can also have the version in this. I guess this looks fine. For street, we can have the street id, we can have the latitude, longitude. I guess anything else, we can also have like kind of name of the street just for storing it. Also, what else do we need? I guess as of now, as per the time being, this is fine. For panorama connection, so how this will work is like when one panorama is created, we are connecting the another panorama along with it. So you can think of like we will be obviously having the unique id, so it would be our primary key. But now suppose this particular panorama is 1, then along with it we are storing the p2 and p3 all together. So the fields would look like, suppose here the street, so here it would be having the street id as our foreign key, and we will be also having like forward and backward meters, right? So we can consider like from 10 meters to from that is like example 10 meters, then to suppose like 1 kilometer. So this is how we can store this all the fields inside it. Basically this will help us to move in any direction faster. Okay, so this is how our system looks like as of now. Let's start with very simple design first, and then we will go into deep dives. This is our hld design. Okay, how it will look like. Okay, let me just design. We will start with a basic design. Suppose there is an user who is requesting for some street view. The request will be sent, and here we will be having the API gateway. Basically API gateway is used for routing request. It is also useful for rate limiting. One thing you need to observe is like when you are using Google Map, you are not required to logging inside it, so we don't need authentication over here. Now we can go with like flow. Like first of all, we will talk about how the data is being captured. That we can consider a scenario. Suppose this is our cameras. These are our cameras, and all of these cameras will capture the raw images, and this will be transferred to some sort of like warehouse where pre-processing of images will be done. You can consider like what we need to convert it into the resolution, like okay, resolution converter. We need to like blur faces and hide number plates. We also need to like see the rules and regulations. rules and regulations, that are we allowed to upload the images of that particular area, because if it is an high alert area and there are some laws that we can't upload it, so we should take care of that as well. Apart from this, we also need to take care, like removing or deleting the duplicate images, because you can consider, suppose if the car is moving in Bangalore, and because of the traffic the car is stuck at particular one place, then it is continuously capturing the data, and we don't want to, like capture the same data and like increase our storage capacity. So we need to take care of like deleting the duplicate images. So for this, some sort of like machine learning algorithms are used to like, okay, here we need some sort of like Kafka kind of system, which will take all of these inputs, and it will use some sort of like Spark streaming service. It's kind of like ML. We can use like ML algorithm, also like some sort of like a Spark streaming thing. We can use like ML algorithm to like for like deleting or blurring all of this things from the image. After this from this, it is been stored in particular storage. This all are like it's a kind of our storage, where we are going to store all of the processed image. Now, after this, we will be having one more service which will take care of like converting the images into different tiles. So you can just consider like all of this things which I have written over here, it will be converted into the services, and you can describe like that. So here from the storage, we are going to store it over here, and now we are converting it into the tiles. So this is like a tile converter, and maybe like we can also use like panorama generator. So this is our final image, and it will be stored in our S3 storage. We need two database, like one is for storing the metadata of all of this images. So now here we can consider this is our metadata db, and this is our S3 storage. As we have discussed, we are having lots of data, that is like petabytes of data and daily, so we need this. And in the bucket form, all of this images are being stored. So here you can consider like whenever we are updating or storing, we are going to update like this. Okay, this particular metadata here, from here we can like take all of these tables. Where is it? Okay, image panorama and all of these things I will consider as a red, oh sorry, black. I will copy this and will put it in this metadata db. Here we are going to use this thing. So yes, now okay, now let's talk about the flow, user flow, like how it will look like. The user can have two things. First of all, like search service, user can search any area, so search service. And second thing is user can have the panorama service, where user can like click on the image. Okay, these are the two service which a user can have. Okay, now let's think of first of all, let's talk about the functional requirements. User can zoom in and zoom out, user can select any street, user can rotate in 360-degree view, we can hide and face height, face and vehicle numbers. This is done. This particular requirements we have covered, how user can move forward and backward, and how fast the images are getting been loaded. This particular requirement and this are like we can discuss it together. Select any street and zoom in and zoom out. I think this will be taken care by our search service. Even like zoom in and zoom out, like it will just show the images, correct? So now let's discuss about our panorama service, how this will work like. Okay, let's think that suppose user have clicked at particular one cell. Now this street latitude and longitude will be passed on, and from metadata db we are going to collect the images and send it to the user. But this whole thing needs to be very fast. So how we can do that, like whenever a search service is been user have like pressed the search, so at that time we are going to load all the tiles of the images at that particular street in the browser of the user. So this needs to be done as fast as possible. So here we can think of like talking about non-functional requirement, we can have some sort of cdns over here. This will be our cdns, content delivery networks, and this here we can store the static files and it will load it, and it will then the cdn will send as a response to the user, as in like list of all the tiles, and it will store in the browser. Now whenever a user is moving forward and backward, basically when a user clicks on that particular street, we are going to send the response of like around 50 meter street images. We will send it and store in user browser. And because of that when the user clicks on forward and backward, that thing will be assured and it will be delivered as faster. Forward and backward, backward, yeah. Now because of this, all the loading of the images or fetching of the images will be faster. Now in the cdns we can set some sort of like ttls, like after suppose after few if the user is searching very not very famous place, then we can save it for around 15 to 20 minutes of the time. We can have some sort of trade-off, like how much time we can store it, but all the hot places will be stored for a longer time. We can also use some sort of caching. This caching will be also useful, so that when a user is searching very famous places, then we can fetch it from here, as this is an in-memory cache. So we will be deleting we will be setting ttls very low. Now why we are going with redis is because sometimes at particular one area event is happening, and over there user want to see, and that particular event might be lasting for 1 day or 1 week. And as it is in memory, it would be very fast. So that's why we can use this redis, because for the particular one location, if the event is very popular, for example ipl match is going on or any concert is there, then people are going to search this particular location, right? But this would be only there for like 1 or 2 days. So we don't need to hit our db again and again, and this is how it will serve the request faster. So this is how our system looks like as of now. There's a possible scenario that there would be some much more questions, but let's discuss like have we covered all functional requirement or not. Zoom in and zoom out. Okay, one more thing is the top view of the whole area, sorry, not area, but for city or country, it's the static image, and over there there is not much change required, and it's been updated very rarely. So we can store those particular images of the countries in our CDNs, and those can be loaded very faster. Just in case if the user is zooming in and a particular street the user want to see, those would be like which that are not the those will take little bit more time compared to the top view images. Okay, now let's see if we have covered all functional requirements. User can zoom in, zoom out, user can select any street, user can rotate in 360-degree view. Okay, this 360-degree view is similar like when we are loading the time. So we are loading, sorry, we are loading the tile, we are loading the panorama. So that particular image is giving you the feel of like we are moving. So that is what we are sending, so that's fine. We are hiding face and vehicle, we user can move forward and backward. Now let's talk about the non-functional requirement, how the low latency will be there as we are using the cache and CDN, so we are able to serve this low latency part. Another thing is we need to make sure our system needs to be highly available. So over there we will be having the multiple instances of all the services, so that even one of the service gets down, our users are not blocked, and we are still our system, we are still able to serve the request, and our systems are like highly available. So this is how we can, you know, like take care of like making our system highly available. Now let's talk about the eventual consistency over here. Now let's discuss one more point, how we will make sure that our images are being stored properly in S3 storage. Here the acknowledgement concept will come, where we need to acknowledge every time we are writing in RDB. So and also we are going to maintain multiple replicas, so we can use the concept where we can say that out of 3 replicas, if 2 replicas are giving yes that okay those 2 replicas got the this data, then we are going to send a response that okay we got this particular data, and we have stored it in RDB. So this is how we will make sure about like our consistency, and to get the response from these replicas will take little bit time. So that's why the eventual consistency concepts will be purpose will be solved. Now we need our system to be scalable enough. So as we are aware about like horizontal scaling, as the traffic is very high, so we will go with horizontal scaling and we will use microservice architecture, and because of that we can take care of scaling. Also we are using MySQL and S3 storage. So S3 is having the ability to auto scale, and in metadata DB, that is MySQL DB, we can use some sort of like sharding if we need more space, and on top of it we can use some sort of indexing. So about this search service and how the search service actually work, we will cover it in the next design, how the elastic search works or how Solar works. So I'm not covering that part in this particular design. Okay, we need it to be durable enough, as we have said that we will be storing it in multiple replicas, so our data loss won't be there. So that's fine. Reliable, we will make sure all the panoramas that we are creating, it is being stored at that particular latitude longitude, so we will make sure that it's reliable, and it should be highly consistent. That is like when you are clicking, it should fetch the proper image. So this is how our system looks like, and obviously we can have more better design than this, but it's not like right and wrong. You can design your system, you can give the proper justification that why your this particular design is correct in the interview. Yeah, so you will find this particular link in the description. So I hope you have learned something from this video. If yes, then please make sure to subscribe to the channel, give a thumbs up, share any doubts in your comments, and thank you so much for watching.